So these are primarily 1C nodes, but we're going to touch a little bit on 1A graphing with dilations. So we have stretches and compressions. So it's all about dilation. It's all about when the number there's a number being multiplied by the parent function. When that happens, there's either a stretch or a compression. So looking at how to work these problems out, you first look at what the parent function is. It's a quadratic. So the coordinates for a quadratic parent function are 0, 0, 1, 1, negative 1, negative 1. Oh, positive 1, sorry. Then we have, so that's the parent function with the key coordinates. Now we do order of operations. So you're looking at, when I say order of operations, it's, think of it like 2 times, in parentheses, squared plus 1. If you put a number in for the x value, any number you want, so let's say 4, what would you do first? Well, you would do, you should be thinking, well, parentheses, but inside the parentheses is just a 4. There's no operation there, so that's done. Then you have exponents, so you're going to be doing the 16th first. So this is going to determine which operations you do first, which transformations. Well, we didn't do any transformation there, just the quadratic. We did that squared. Then you do multiplication. So this means that we need to do the dilation next before we do the up. So dilation, what you do is you multiply the y value by the dilation. So we're multiplying by 2. So this is going to change our coordinates, our key coordinates. The x's are all going to stay the same. And you multiply each y value. So 0 times 2 is 0. 1 times 2 is 2. 1 times 2 is 2. And I'll show the times 0. So now these are our new points. These new points, put those on the graph. So we have 0, 0, 1, 2, and negative 1, 2. Now redraw the graph. So as you see, from the parent function to, when we do a dilation in this case, this is compressing it. Or no, sorry, it's stretching it. It's making it thinner. So this is a stretch. If the number is greater than than 1, there'll be a stretch. If the number is smaller than 1, compress or shrink. This is dilations. I should say greater than the absolute value of 1 and smaller than the absolute value of 1. Because really we're looking at the smaller means it's a fraction that's less than 1, and greater meaning it's positive or negative 1 or greater. So it could be like negative 2. The absolute value, that's 2. That gives us a stretch. All right, so this is a stretch. And then we need to take the black points and move them all up 1. So order of operations, we did 2 times 16 is 32. And now you do the plus 1. And that means we got to go up 1. And again, this is just over here on the left is just to show order of operations. That has nothing to do with the actual points, with the numbers I'm coming up with. This is just to figure out which order to do the transformations in. So I move each point up 1 and redraw it, and the red is our actual answer. So let's do this again. So for number 2, we have order of operations. I'm not going to draw it out again, but we do subtract 1 first. First it's cubed, so cubic functions 0, 0, 1, 1, and negative 1, negative 1. 0, 0, 1, 1, negative 1, negative 1. Cubic function, real tall, slide. Looking at order of operations, the x is right here inside the inside, so we would subtract 1 first. So each point, we're going to subtract 1 first. So that means go right 1. So each point, we're going to move to the right 1. Looking at those coordinates now. So those coordinates would be 2, 1. So I'm going to draw another coordinate plane, or a T-chart. 1, 0, and 0, -1. So 0, -1, 1, 0, and 2, 1. Our next, so that's the first order of operation we need to do. Let's go right 1. Now the only other thing is the dilation. And with the dilation, when it's just multiplied by the parent function itself, we are going to be multiplying the y by the number in front, what it's being dilated by. So it's being dilated by 1/3. So when we do this, we're going to have fractions. -1 times 1/3 is a -1/3. 0 times 1/3 is 0. And 1 times 1/3 is 1/3. So if you're like, wait a second, how do I draw that now? How do I get those points? So 0, -1/3. I'm just going to go down a little bit less than half. 1, 0 stays the same. And 2, 1/3, so I'm going to go just up a little less than half. These points are never exact, but this is a good estimate. So if you see, the graph kind of flattens out a little bit more. So this is a compression. It flattens, it compresses. All right, so that's dilations. Moving on to today's work. So we have zeros, y-intercepts, and end behavior. Zeros, these are x-intercepts, where the graph crosses the x-axis. Y-intercept, where so this is graph crosses the x-axis. And the y-intercept is where the graph crosses the y-axis. End behavior, these are talking about the direction of the ends of the graph. Direction of the ends of the graph. And I'll talk a little bit more about that in a little bit. So look at that number 1 here. 0, zeros are where's across the x-axis. So this is at -3 and -5. So there's your zeros. The y-intercept, where's across the y-axis? Well, I can't really tell, so I'm going to estimate it. So I'm just going to keep going up, and we're going to estimate it. So if this is 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, we'll say that's 16. So sometimes you have to estimate where it crosses. Now, end behavior. End behavior is talking about the ends of the graph and which direction they're going. So this is kind of thinking about how far will they go in those directions. So you have 2 directions. So I'm going to start on the left side here. There's 2 directions. How far left will this graph go? And you should say that this end of the graph is going to go left forever to -infinity. And how high, since it's going up, how far up will it go? Well, it's going to go to +infinity. These right here, we're going to incorporate in the first one. Left is your x value, and up is your y value, which I'm going to put as f of x. So left is going to -infinity. This is left. And the y value then is going to go up to +infinity. So let's do this with another one. Your other side, which 2 directions is it going? It's going right, and it's going up. So how far right will that graph go? Well, it's going to go right forever to infinity. And how far up will that graph go? Well, it's going to go up to infinity. So these two we're going to put down in the bottom here. As x goes to positive infinity, that's how far right it will go. The y value is going to go up to positive infinity. And there's your end behavior showing the ends of the graph, where they're going. Example 2. So zeros, it could be zeros. It doesn't even, it could have none. So it looks like we have a -1. We're just going to estimate these. That one's a little over 1, so we'll say 1.3. And that one's a little over 2, so we'll say 2. I'll just say 3 again. So our zeros are -1, 1.3, and 2.3. The y-intercept looks like where it crosses the y-axis is pretty close to 3. End behavior, so we'll start on the left arrow here. Which two directions is going? It's going left forever, and it's going down. So it's going left. How far left will it go? It'll go to -infinity. And how far down will it go? It'll just keep on going to -infinity. So this is how left. Look at which x value means left. The top one does, because x is going to -infinity, just like the left x is going to -infinity. Down is the y value. So the y is going to go down to -infinity. Looking at the right side of the graph, the right arrow end of the graph, to which two directions is it going? Is going right and up. How far right will it go? It'll go to infinity. And how far up will it go? It'll also go to infinity. So as x goes to positive infinity, that's the right. What we have up here, the up, which is the y value, will go to positive infinity.